Jai Hind student, this is the fourth lecture of satellite communication subject. In the previous lectures, we discussed about the satellite definition, then the type of the satellite and the services offered by the satellite. In this particular lecture, mainly we are concentrating on the frequency spectrum that is used for the satellite communication. So, the frequency spectrum, as you know that as when we are talking about the frequency, what is frequency actually? Actually, frequency is defined as the movement of particle in particular cycle or the cycle repeated in a particular time, that is called frequency. If formula is concerned, F is equal to 1 upon T. In the simple language, I can tell you frequency is the number of cycles in per unit time. So, if I am talking about the frequency and wavelength relation, that is F is equal to C upon lambda, where C is speed of light or speed of electromagnetic waves, where lambda is the wavelength. It means as far as frequency is increasing, wavelength is decreasing. This is thus the prerequisite part of the frequency. So, about the electromagnetic spectrum, actually a wide range of frequencies are available for the users for different uses, that are basically classified into radio frequencies, microwave frequencies, infrared, ultraviolet, X-ray and gamma rays. Out of these frequency range, only the frequency band between infrared and ultraviolet is called visible. That is visible frequency spectrum or visible electromagnetic spectrum, that is visible by our eyes only. For this complete spectrum, that is the broad communication spectrum, as far as frequency is going down, wavelength is increasing. It means if a particular radio signal is concerned, its frequency is low but its wavelength is quite high. It means frequency is low, wavelength is quite high, means its energy is also low, because energy is directly proportional to the frequency. As well as that frequency is increasing, energy is also increasing, but wavelength is decreasing. So, here I want to tell you one very special point which is required, that whenever you want to design an antenna for an individual system, because antenna is also a very major part of a satellite communication system, antenna height is always lambda by 4. It means if any signal having a wavelength of 1 meter, it means the length of antenna for that particular frequency is 0.25 meter, 1 divided by 4, 0.25 meter. It means as well as frequency is increasing, the height of antenna is decreasing. For the high frequency, that length of antenna is also very small. As you know that your mobiles are working on microwave range, gigahertz range, megahertz to gigahertz range. So basically in that region, gigahertz range, that is related to 10 to the power 9. It means 10 to the power 9 meter range. If I am talking about the antenna height, it is quite small. That's why your antenna having printed antennas on the motherboard or on the circuit board of the mobiles. This is the basic prerequisite knowledge about the antenna relation, the frequency relation, the energy relation and the wavelength relation for all that. Now, for the frequency band which is used out of this spectrum for satellite communication is this. That is situated between 1 to 40 gigahertz. If you can easily understand here that this complete frequency spectrum is divided into various frequency ranges that are VLF, very low frequency, from 3 kilohertz to 30 kilohertz, used for maritime navigation signals. When we are talking about 30 kilohertz to 300 kilohertz, it is low frequency that is used for the navigational aids, Lorenzi, for the landing of the aircraft on the airports. Then the frequency range of 300 kilohertz to 3 megahertz, that is for medium frequencies, that is used for maritime radio. For shortwave communication, 3 megahertz to 30 megahertz range of high frequency signals are used. More than that, VHF and UHF, that are very high frequency and ultra high frequency, used for FM radio, navigation aid, cell phone, GPS also, and the frequency range lies between 30 megahertz to 3 gigahertz. If you recall the previous use of the television, when the analog television or the just digital has been started, in that time you easily understand when you are changing the channels of the TV, you are having some channel in VHF band and some in UHF band. Basically these are both are the those particular bands which are used for the television communication, VHF and UHF band channel allocation. Similarly, for the super high frequency, that is for satellite and microwave telecommunication. Or the next one is extreme high frequency from 30 gigahertz to 300 gigahertz, radio astronomy and radar landing systems. It means out of this complete range, only this range, means super high frequency range, is used for satellite communication. And more specifically, 1 to 40 gigahertz frequency band is used for this satellite frequency range. This particular complete band is divided into 7 bands, satellite frequency bands. First one is L band, that is between 1 to 2 gigahertz. Second is S band, 2 to 4 gigahertz. C band, 4 to 8 gigahertz. X band, 8 to 12 gigahertz. KU, 12 to 18. K, 18 to 26 and KA, 26 to 40 gigahertz. Basically, KU and KA stand for K under, K under, K band and K above. Also, you can see one point here. The frequency band is continuously increasing as well as frequency is increasing. Whether S band is only having a bandwidth of 1 gigahertz, whether this particular K band having a frequency bandwidth of 14 gigahertz. These three initial bands are used for domestic. These are used for domestic purpose only. Whether this KU, K and KA are used for extraterrestrial operations and X used for the military application. So this is the satellite frequency allocation. Then the parameters, or we can say that the properties. When we are talking about the properties of these satellite spectrums, first one is bandwidth. As far as we are going towards the higher frequency, the bandwidth is increasing. For the L band or the domestic band, the bandwidth is small. Whether the extraterrestrial purpose, the bandwidth is high. In this point, you can see that for the K band, that is 14 gigahertz. Whether in the previous one, that is less. Whether L is only 1 gigahertz, S is 2 gigahertz. Then the antenna size. As I told you earlier, that frequency is F is equal to C by lambda, and antenna height length is always fourth minimum length of the antenna for a particular frequency is lambda by 4. It means if the wavelength is high, length of antenna is always large. If wavelength is small, it means frequency is high. That means antenna size is small. That's why you can see that for the L band communication, they are using large antenna, dish antennas. Whether when we are talking about the outer space communication, extraterrestrial communication, the antenna size is small, quite enough compared to the domestic purpose. Then about the attenuation. Attenuation is basically related to the susceptibility to rain, fade or other interferences. It means these are some other point are also susceptibility and throughput. Now question arises, what is throughput? Actually, when a particular communication system is sending the data or receiving the data, then how much amount actually it is sending or receiving, that is defined by the throughput. So as far as domestic point of view is concerned, for the LSC bands, the throughput is low, whether for the KA, K and KU band, that throughput is high. Antenna size and spectrum bandwidth is already discussed, but the susceptibility is also a very major concern. Susceptibility, when we are talking about the susceptibility of any system, then this is the ability of toleration by the system. If we are talking about a communication system, then it is about the noise susceptibility. Means if I am using a communication system and that is very susceptible to the noise, it means communication will not in the proper shape, because the system is susceptible to noise and noise interference will create large distortion in the communication. But when we are talking about this satellite communication complete part, as well as this frequency is increasing, this susceptibility will also increase. In the previous lectures, I also told you about some specific kind of point regarding that uplink and downlink frequencies. I told you at that time, at C band, the fading is less, and as well as frequency is increasing, the outer atmosphere of Earth will create more fading or more attenuation in the signal transmission. So basically, when we are talking about these susceptibility point of view for these bands, as far as increase in frequency, that susceptibility to fading, rain fading or path loss attenuation, that will also increase. So when we discuss about the various uses of individual these L band, S band, KU band, KA band, X band, then these are some specific point which you can easily understand, and that is very helpful for your examination purpose because it is all about the parameter. So when we are talking about the L, S and C band, as I told you, L, S and C band are basically used for domestic purpose only. So L band is 1 to 2 gigahertz and it is used for global positioning system, GPS carrier and also for satellite mobile phone such as Iridium, that is a system, Inmarsat providing communication at sea, land and air, World Space Satellite Radio. So this is the application of L band. Then the second point, S band. S band is situated between 2 to 4 gigahertz, which is basically used for weather radars, surface ship radars, some communication satellite, especially that are designed for the NASA, especially offering ISS, International Space Station and space shuttles. This is not inter-satellite link, that is not inter-satellite services. This is basically International Space Station. So for the communication with the International Space Station and space shuttles, NASA is using this S band. This is some specific fact that in May 2009, Inmarsat and Solaris Mobile, a joint venture between Eutelsat and Astra, was awarded each a 2 into 15 megahertz portion of S band by the European Commission. Actually, this point here arises from ITU, International Telecommunication Union. This complete frequency band allocation, the frequency allocation or spectrum allocation to various users for a specific purpose, that all points are governed by the ITU. They are providing the spectrum and they are monitoring and regulating all the protocols and the conditions for the use of specific spectrum for a specific purpose. So basically that European Commission, ETO, that is used, and that this is the one example of that. Then C band. Basically C band lie between 4 to 8 gigahertz and it is primarily used for satellite communication for full-time satellite TV network and radio satellite feed. Also, it is used where they are subject to tropical rainfall. As I told you in the uplink and downlink frequency slide, that C band is mostly or widely used because this particular C band having the least attenuation or path loss due to the rain. That's why this C band are used for the satellite communication with the full-time satellite TV network. Now, the X band. X band lie between 8 to 12 gigahertz and this is primarily used by the satellite, used by the military for the radar application, for continuous wave radar, pulse radar, single polarization radar, dual polarization radar, synthetic aperture radar and phased array radar. These all types of radar, basically radar. What is radar? Radar stands for radio detection and ranging. Radar is a unit in which electromagnetic waves are created by a transmitter that going towards the object. They hit the object and reflect back from that object towards the radar again. Radar receive that particular electromagnetic wave which was transmitted by it, and then calculate the time to go and come back to the radar, and as per that time the distance and location of that object will be identified. So this is basically radar, and there are various kind of radar that are used in the military, and that all radars are basically using this X band, 8 to 12 gigahertz frequency band. Also X band radar frequency sub-band are used in civil, military, government institution for weather monitoring, air traffic control, maritime use, traffic control, defense tracking and vehicle speed detection. You can see on the traffic points many times that a small vehicle speed detection radar is placed on the mounted on the gypsy to monitoring the speed of the moving vehicles. That is working on the sub band of the X band radar. That is the commercial use of the X band. Other than that, this is Ku, K and Ka band. Basically, they are used for outer space exploration. So Ku band, that is of 12 to 18 gigahertz, K band 18 to 26 gigahertz and K above is 26 to 40 gigahertz. Basically Ku band used for the satellite communication, in Ku band downlink used for 10.7 gigahertz to 12.75 gigahertz for direct broadcast services. K band is used for short range communication, whether K band is used for high resolution application of the communication satellite, in which 27.5 gigahertz and 31 gigahertz band are specifically used for close range targeting radar on military aircrafts. So this is all about the frequency band allocation and frequency band or frequency spectrum used by the satellite communication. In the next chapter or in the next lecture, we will discuss about the another points related to the satellites communication, such as debris, satellite debris, space debris, and the introduction of geostationary and geosynchronous satellite. Till then, thank you.